Alright, welcome back to my channel once again. I remain your online tutor, Mr. Eze. Remember, in our previous lesson, we opened a discussion on matrix. There we discussed how we can add matrix, how we can subtract matrix, and then how we can multiply a matrix. Today, I want us to look at determinant of a matrix. Then after that, we're going to look at how you can transpose a matrix. Now, what is determinant of a matrix? Before we delve into the determinant of a matrix, I want to implore you, if you have not watched the earlier video, the part 1 of this video, please do me this favor, get the part 1 of this video, go through it so that it can lead you to the part 2 of this video. But then, if you have not subscribed to my channel, hit the subscribe button, hit the like button, and then share this video with your friends. If I can tell who will be in need of this tutorial. Now let's proceed. Determinant of a matrix. What is determinant of a matrix? Now, it's just simple, just a single value, just a scalar value or a scalar quantity, scalar value determined from a square matrix. Of course, we know the square matrix. Square matrices can be 2 by 2 matrix, can be 3 by 3 matrix, can be 4 by 4 matrix. This square matrix, like we said, can be a 2 by 2 matrix. If it's a 2 by 2 matrix, for example, for 2 by 2 matrix. For 2 by 2 matrix, if we say if A is a matrix of 1, 2, let's say minus 2 and then 1. Now, how do we find the determinants of this matrix? Of course, like we said, just a single value. This is a 1, 2, 3, 4. At the end of the determinant will give you just a single value. So if A is this, now find the determinant. Determinant of A can be written as this, or it can be written as delta A. Most books will use delta A, while some will use this. Whichever be the case, do not get confused. Any of them can go. Now, how do we find the determinant? How do we get that single value? It's just gotten by the diagonal. We will take the diagonal, the right diagonal minus the left diagonal. Therefore, if we have A is this, find the determinant of A or absolute value of A. Now we now have that if A is this, therefore the determinant of A will now give us, we take the right diagonal like this. If we take the right diagonal minus the left, we take the left like this. So which will now give us 1 times 1 minus, we have here minus 2, of course, minus 2 times positive 2. Which will now give us that the determinant of A will give us 1 times 1 is 1. Open this bracket, minus, if you open that bracket, gives you plus. 2 times 2, 4. Therefore, we can now have that the determinant of A is equal to 5. We can take another one. Now, given that Q is equal to 1, 2, 5, and 6. How do we find the determinant of Q? The determinant of Q will give us, just like we said, do not forget to take the right diagonal first, minus, you take the left diagonal. Always take it like this. 1 times 6, which will give us 1 times 6, minus what you have here, minus 5 times 2, which will give us 1 times 6 is 6, 6 minus 10. Therefore, the determinant of Q will now give us 6 minus 10. Of course, it will give us minus 4. So these are single values. These are single values. Now, this is for a 2 by 2 matrix. What if we look at 3 by 3 matrix? Will the same procedure go? And of course, we need to step up on the procedure if you are going for the 3 by 3 matrix. Let's see how it works. Now, we have for 3 by 3 matrix, of course, it's not going to be the same. Now, in this case, this is we refer to this as the first matrix. All we need to do is very simple. Split this into smaller matrices, into smaller 2 by 2 matrices, by bringing out what we call the cofactor. Of course, the cofactor is that the leading number in the element of that matrix. For example, once we have this on the board, you cannot carry it out like this. If you want to bring it out, what we need to do is we can, if you are taking this column, the first number in this column, bring it out. For example, the first number in this column is the 5. That means 5 is now the cofactor. But then we have rules. The rules that guide this is that in creating the second matrix, these rules will have the first one must start, be conscious of the signs. The first one must start with a positive sign, followed by negative sign. The other one is positive. Now we have this other one. Immediately after the negative sign, or positive sign, we'll have a negative sign here. We'll have the positive sign. Distribute these signs. Make sure that none of the signs is repeated, either in that column or in the row. Now, immediately after this negative sign, what we have is the positive sign. And of course, here, after negative, we have positive. After negative, we have positive. Of course, the next thing that follows is negative. This one is a negative, and then somewhere here is a positive sign. Now, we can close this. Now, we now distribute this, bring out the smaller matrices. Like we said, the leading element there on this column is 5. Now, we can have 5 into, of course, once you bring that 5, block that row, block the column, repeat the numbers you have. And of course, if we block this one, we now have, remember this is 5. If we block here and here, we have this remaining 4, 2, 7, 6. We have this. Now, remember, the next sign that follows is the negative sign. Minus. You leave this column, enter this column, bring out the first number there, which is 2. So in that case, we now have minus 2 into, just like we said before, now that we have picked this, block this and block this. Whatever that you have left, of course, the 2 is out. Bring out like this. Of course, what you have is 3, 1, 2, and 6. So we have it 3, 1, 2, and 6. Now, the next one is plus. Remember, we're done with this. We're done with this. We're now in this column. Pick the first number 1 into, just like we said, since we are here, block here, block here. Whatever that is remaining, write them out, which will now give us 3, 4, 1, 7. You close it. Now, after distributing it like this, it makes the work very easy. You can now take that the first step we took. We can now see. So when I have 5 be outside, remember we said multiply. Take the right diagonal. The right diagonal minus the left diagonal. 4 times 6. 4 times 6. 4 times 6. Okay, so I can now, let me use open brackets. So when I have 4 times 6 minus the left diagonal. The left diagonal is 7 times 2. 7 times 2. Remember? Minus, you can now close this, minus 2. You open a bigger bracket, this 2 is here. Now remember, the same way, 3 times 6, open the smaller bracket, 3 times 6, close it, minus, you take the left diagonal, 1 times 2. You can close these brackets, plus 1. Open that bigger bracket, the smaller one, take the right diagonal, 7 times 3, which is 7. That's 7 times 3, minus, you take the left diagonal, 1 times 4. You can close that bracket. Now, what do we have here? We can have 5, bring your 5, 4 times 6. Open up another bracket there. 4 times 6, and of course, 4 times 6 is 24. We can say 24 minus 7 times 2. So, of course, 7 times 2 is 14. Minus 2. 3 times 6 is what? 18. Minus 1 times 2. 1 times 2 is 2. You operate the bracket there. Plus 1 into 7 times 3. 7 times 3 is 21. We can have 21 minus 1 times 4. 4. We'll have it like this. Now, at this point, you can now deal with the values in the brackets. So when we now deal with the values in the bracket, we now have 24 minus 14. And of course, 24 minus 14 is 10. 10 times 5. Now, we can now have, or you can say 5 times 10. Either is it like this, or take whatever. Let's take it step by step. 5 into 10 minus, you have your 2 into, deal with the values in the bracket. 18 minus 2. Of course, 18 minus 2 is what? 16. Plus 1 into 21 minus 4 will give us 17. So we now have it. So everything will now give us 5 times 10. 5 times 10 is 50 minus 2 times 16 is 32 plus 1 times 17 is 17. At this point, you can now subtract, which will now give us 50 minus 32. 50 minus 32 will give us 18. 18 plus 7 will give us 35. Therefore, we can now say that if A is this, the determinant of A is equal to 35. Remember, we said that this determinant is just a single value, just a scalar quantity obtained from this whole numbers. Now, we talk about the transpose of a matrix. Transpose of a matrix is nothing but an entirely new matrix obtained just by interchanging the rows and the columns of a particular matrix. For example, if you have that matrix A is given as, let's say, 2, 1, 5, 7, minus 3, and we'll have 0 here. Now, of course, if you look at it, this is row 1, row 2, row 3, column 1, column 2. Of course, this is a 3 by 2 matrix. Now, if we have this by transpose, transpose means change the rows, these rows, this column here, turn it into row. And transpose is expressed as, let's say, if you have A, the transpose of A is expressed as a raised to power t. Now the transpose of this value is given as, all we need to do is we take, this is, if you're taking this row, this number become the first, you now go like this. Second one will have 5, will have -2. Now we take this one here, which is 1, 7, and 0. Of course, this is a transpose of A. What we do is just, anyhow you want to do it. If you want to transpose the rows, if you want to transpose the row, that means this row, if you want to take it by row, that means this will have 2 here, this one will now come here. Simple. Now, this one, 5 will come here, while 7 comes here. Now, -2 will come here, while 0 comes here. So look at this and this, they are the same thing. This one, I took the rows first, whereas this one now, I just transpose the columns. Pick the columns one by one. Whatever you have here, as you go down like this, it will be going to the rows. Simple. Change this column into row. That is what transpose is all about. Now, you may be given a particular value. Now, if you are given a particular value, all you need to do is convert it into either row or column, and it gives you the transpose. Simple. Now, we have this problem on the board. We have if matrix A is this, matrix B is this. Determine A dot B transpose. If you see this type of problem, don't get scared. All you need to do is, remember, the transpose is outside. You know that this thing is different from A transpose dot B transpose. They are different. These are two different things. All you need to do is find the multiply A and B. By the time you multiply A and B, whichever value it gives you, transpose it. It will give you this. Now, let's go. And remember the rule. The rule says we bring this and this together. If we bring this and this together, we have 2, 7, 6, 3, 1, 5, dots, 4, 3, 1, 0, 7, 5. This is what we have. And if we have this, what do? Open a larger bracket. Open a larger bracket. And if you open a larger bracket, what do we do? Remember, this one is row 1, row 2. Column 1, column 2, column 3. That means this one is a 2 by 3 matrix multiplying row 1, row 2, row 3, column 1, column 2. That means a 3 by 2 matrix. Remember the rule? The rule says, of course, when you multiply this and this, it will now give you, the product will give you a 2 by 2 matrix. Now, let's pick it together. As usual, we take the row and multiply the column first. It will give you what you have here. Use the same row, multiply this column. It will give you a second value. Take the row, multiply this, take the second row, multiply this first one, it gives you here. And then when we take it to multiply the second one, it gives you the second value here. Now, let's do it. Now, we have the first one, 2 times 7, sorry, 2 times 4. 2 times 4 plus will come here, 7 times 3. 7 times 3 will give us this. Now, plus, we'll have 6 times 1. 6 times 1, of course, you separate it. When you now separate it, we have, use this same rule to multiply this. And when you do that, we have 2 times 0. 2 times 0 plus 7 times 7. 7 times 7 plus 6 times 5. 6 times 5. Write it. Now, I'll move down to the second row. Use the second row to multiply it. 3 times 4. 3 times 4 plus, I have 1 times 3. 1 times 3 plus 5 times 1. 5 times 1. I am done with this. We'll still use this and multiply this, so I'll get the value we'll have here. So which will now give us 3 times 0. 3 times 0 plus 1 times 7. 1 times 7 plus 5 times 7. So at the end of the day, remember there's a comma here, meaning that I have now obtained my 1, 2, 3, 4. So we'll take it. So if we take it here, we'll now have 2 times 4. Of course, 2 times 4 will give us 8. So here will give us 8 plus 7 times 3, 21 plus 6 times 1, 6. So if we now add 8 plus 21 will give us 29. 29 plus 6 will give us 35. So I can have 35 here. I will now come here. 2 times 0 is 0. 7 times 7. 7 times 7 is 49. Plus 6 times 5. 6 times 5 is 30. Now, 30 plus 49 will give us 79. So we can now have here 79 here. We come to this one to have 3 times 4. 3 times 4 is 12 plus 1 times 3, 3 plus 5 times 1, 5. So 12 plus 3 will give us 15. 15 plus 5 will give us 20. We just write 20 here. Now we come here. 3 times 0 is 0. Now 1 times 5, 1 times 7 is 7 plus 5 times 7. 5 times 7 is 35. Now 35 plus 7 will give us 42. Now remember, this is just A dot B. A dot B is this value. A dot B is 35, 79, 20, 42. This is A dot B. But the question says A dot B transpose. Therefore, we're going to transpose this. If we transpose this, we'll now have the A dot B transpose will give us, as usual, we'll take 35 here. So take 35 here. This number that is here, you bring it here. It becomes 79. This one, you take it here, 20. Then this number that is here will remain here. Therefore, the answer to this question, if A is this, B is this, AB transpose is this value here. Of course, this is where we'll draw the lesson to an end. If you have not subscribed to my lesson, please hit the like button, hit the subscribe button, and then please forward this video, share this video in all your social media platforms, because this particular transpose of a matrix is always and every year question. And of course, it knocks students off balance. So we do this, simplify this, so that students can have this on their fingertips and in every exam they are going into. Alright, so see you in my next lesson, where I'll be bringing you adjoints of matrix. Bye-bye.